Another challenge for the real-world deployment of AI models is that we need metrics to reflect clinical application. We've seen some ways of evaluating models we've built, which included looking at the area under the ROC curve or looking at the DICE score. In the real world, however, we want to be able to look at the effect of our model on real patients. Specifically, we care about measuring whether the model eventually improves patient health outcomes. One approach to this challenge includes decision curve analysis, which can help quantify the net benefit of using a model to guide patient care. Another approach is to see what happens in the setting of a randomized control trial, where we compare patient outcomes for patients on whom the AI algorithm is applied versus those on whom the AI algorithm is not applied. We will look at the setup of randomized control trials in Course 3. In the real world, we would want to analyze the effect of the model not just overall, but also on subgroups of the population. This would include patients of different ages, sex, and socioeconomic status. And this allows us to find key algorithmic blind spots or unintended biases. For example, skin cancer classifiers that can achieve a performance level comparable to dermatologists when used on light-skinned patients have previously underperformed on images of darker skin tones. Algorithmic bias is an important and open area of research, and in Course 2 on medical prognosis, we'll walk through one scenario in which something as simple as misusing missing data can lead to biased models. Finally, one of the major challenges and opportunities to applying AI medical models in the real world is achieving a better understanding of how these algorithms will interact with the decision-making of clinicians. One of the limitations of AI models, even the ones we've looked at in this course, is that it is difficult and often impossible to understand the inner workings of models to understand how and why they make a certain decision. In Course 3, we'll look at how we can go about interpreting the chest X-ray model we've built and a few different ways of getting insight into the clinical decision-making process of these algorithms. Congratulations on completing this week on building medical image segmentation models for medicine. You've learned about MRI data, deep learning architectures and loss functions for segmentation, and evaluation methodologies. In this week's assignment, you will get to see how all these ideas go into building and evaluating your own model for segmenting brain tumors. Finally, you are now also aware of some of the challenges and opportunities that are associated with making these models part of clinical care.